So this is video number 1 for chapter 5. It is actually covering the pre-targets and something we call the DIRT formula, and it comes before section 5.1, so it's kind of the introduction to chapter 5. So there's 3 targets that we're going to cover here, and yes, you should write these down on your paper. We are going to be simplifying ratios, which is a review, simplifying ratios and fractions, something that you have done before, but we need it a lot in this chapter, so we'll review it. Identifying and finding equivalent ratios and fractions, again, something that's review, and then the DIRT formula. So let's go over some simplifying first. If I give you a fraction or a ratio, either one, we're going to kind of use those interchangeably in this chapter, you should be able to reduce it or simplify it, write it in lower terms, smaller numbers. So to reduce something, we want to find a factor that we can divide by, that the numerator and denominator can both be divided by, and then divide by that. So in my first example here, I'm going to divide by 12. Because I know that 12 can go into 12 and into 124, and then it would reduce or simplify down to 112. And in the next one, I have 15 and 25. Well, I know in my multiplication facts that 5 goes into both of those. So I'm going to divide the numerator and denominator both by 5. And I get 3/5. Okay? So I'll do 2 more, and then you can practice the next row. Again, I know this is review, but it's something that we have to be able to do in this chapter. So when I look at number 3, multiplication facts, I know that 8 goes into both of them. So let me divide by 8, and I get 8/10. Now, if you look at that one, you can see that there's still something, another factor that goes into 8 and into 10. I could divide both of those by 2. So if you ever are reducing or simplifying and you realize that there's still something else you can divide by, you got to keep going all the way until there's nothing left. So I get 4/5. All right, and then the last one, I can see that 4 goes into both of these, and that would give me 4/6. And if I realize that's not simplified all the way yet, divide by 2 again, and I get 2/3. I could have also realized that 8 goes into both of these. If I divide by 8, I get right to 2/3 as my final answer. So don't be afraid if you aren't sure what the greatest common factor is. At least start somewhere and try it, and then keep going if you need to. So I'll let you do the next row. These are the practice on your paper. Pause and try these, and then play and check. Okay, I've put the answers up here and I showed what I divided by. Again, I know this is review, but it's something we're going to use a lot in this chapter. So check those and then we'll keep going. So you also need to be able to tell if 2 fractions or 2 ratios are equivalent. So here's 4 examples, and I'm going to give you 2 strategies. The first strategy is to simplify them both and see if they simplify to the same thing. So if I use that strategy on the first one, let me think about what goes into 15 and 60. Well, I could divide by 5. Let's try that. If I divide by 5, I would get this. So I would get 3/12 and 3/4. Well, when I simplified them both, I can tell those are not equal. So they're not equivalent fractions, not the same. 3/12 is obviously not equal to 3/4, or I could even take this further and say 1/4 is not equal to 3/4. So your answer is no, not equivalent. What about the next one? Well, if I take 24 and 144 and try to simplify that, let me try dividing by 12. I know 12 goes into both of these, and that would give me 2/12. Well, 2/5 is not equal to 2/12, or this could also be written as 1/6, but again, it's not equal to 2/5, so they're not equivalent. The other strategy I want to show you is that you could divide them on your calculator and get decimals. Okay, so if I have 15/20, I could divide 15 divided by 20 on my calculator, and it says 0.75. And then if I divide 3 divided by 5 on my calculator, right? If I type in 3 divided by 5, that gives me 0.6, and I can tell that those are not equal. So that's another strategy. Divide them and get decimals. So let's try the last one really quick. 2 divided by 8, and 16 divided by 64. Those do give me the same decimal. So the answer here would be yes, these are equivalent, but the rest of them are not. Okay, another type of problem you're going to see is where you have to kind of fill in the blanks to complete the ratio. So if I give you one ratio that is equal, or one ratio here, 6 to 7, and I say that it's equal to another ratio, but written with different numbers, you have to fill in the blank to make it true. So the strategy for these is to think about what are you multiplying or dividing by, right? I can kind of think of this as like 6/7 and then something over 42. And I can tell here that I'm multiplying by 6. So this number needs to be multiplied by 6. So I can tell I would get 36 here. It's a little harder to see when it's written in the line like this, right, in one horizontal line, but we can still figure it out. This got multiplied by 6, so this needs to get multiplied by 6, and we get that 36. So let's look at the next one. Okay, the first numbers go together, and the second numbers go together. So I can tell here that the 2 got multiplied by 9, so the 5 would have to be multiplied by 9, giving me that. Okay, so I'm going to draw the arrows in, but then try to fill in the blanks on the next two. All right, so the first numbers go together, and then I'm going to use the second number to figure out that one. And then same thing here, the first numbers go together, and then the second numbers go together. See if you can fill in what would go in those blanks. So try to figure out what those arrows are telling you, and then what would the blank number be. So pause and try them. So in this first one, I can see it's being divided by 3. So 12 divided by 3 would be 4. In the second one, my arrow is 28 being divided by 7. So 77 divided by 7 would give me 11. Okay. So the last kind of problem I want to talk about is these, and I know they're a little bit blurry. It's not super clear, but just a whole string of equivalent fractions. Okay, looking at this one, I can see that I'm starting with 7/5, or 7 over 5. And I want to know what would go in all of these blanks to make them true. So we're going to start where these kind of make a pattern to see how they work, and then you might see some later in the chapter where they're a bit more complicated. But I'm still going to use my arrows to fill in and figure out what's happening each time. So you notice here, this got multiplied by 2. Well then, this is going to have to get multiplied by 2, and I would get 10. Okay? And the next one, if I keep going, well now the 5 got multiplied by 3. So the 7 is going to get multiplied by 3, and I'd get 21. Okay? You could also check all of these, because if I go back, 14 over 10 would simplify to 7/5, and 21 over 15 would simplify to 7/5. So they're all going to simplify back to the same thing that I started with. Okay, so let me keep going. This gets multiplied by 4, so 7 times 4. And then I'm moving across now. 7 gets multiplied by 5 here, so 5 times 5. Okay? So we're just counting up, kind of making a pattern here, but you can see how these equivalent fractions work. All of these fractions end up being equivalent. If I keep going, 5 times 6 to get this one, so 7 times 6. And then 7 times 7 to make 49, so 5 times 7. And the last one, 5 times 8 to make 40, so 7 times 8. Okay? So you try the bottom row. The whole bottom row, fill in all those blanks to make the equivalent fractions. Okay, so I've shown what I multiplied by in each one and then filled in all of the blanks. So each of these would be equivalent fractions. So there's these problems and the next section here these ones. Try both of these now as practice on your paper, and then we'll go back and check those. Okay. Okay, so you can see what we did each time and then what I got for the answers. Okay, so you should be able to pick the equivalent ones out of the list. And in this one, I drew the arrows in. The clue or the hint here I'm going to tell you is that your arrows always need to go towards the missing number. So my arrows are always going towards the blank that I'm trying to find. That'll help you make sure you're whether to multiply or divide, which way are you supposed to go. So draw your arrows in towards the missing number, figure out what those arrows are kind of telling you to do, and then you can fill in the blanks. Okay, so the last piece of this video is the DIRT formula. So this is the DIRT formula. It helps us find distance, rate, and time. There's a formula that distance equals rate times time. But sometimes they ask us for the rate or the time, so we're going to go through how to easily get those, okay? So first of all, I'm going to fill in that D is for distance, R is for rate, and T is for time. Okay, so this is talking about how fast things are going and how long it'll take you to get there and how far you go. Okay, so we're going to figure out the formula for each one. Now to do that, we're going to write D, R, T in my triangle here. Okay, so we already said that distance is the rate, how fast I'm going, multiplied by the time, how long I'm going for. Okay, so the distance formula, if I want the distance, D is equal to the rate times the time. Rate, R, if they're looking for how fast you're going, I can go back to my triangle. And the rate here is going to be the distance divided by the time, right? So rate is distance divided by time. And then the last one, if they ask me how long it takes and I'm looking for time, time is equal to the distance divided by the rate. So time is equal to distance divided by the rate, okay? So we're going to go through and do one quick example of each one, and we'll do more in class together. All right, let me fill in my DIRT triangle. First question says you bike 28 miles in 3 hours. So let me figure out what I have here. 28 miles, that's a distance. 3 hours, that's a time. And if I have a distance and a time, then I'm looking for the rate. So back to my triangle, we said the rate is equal to distance divided by time. So the distance, 28 miles, divided by the time, 3 hours. If I do that quick on my calculator, 28 divided by 3, I get 9.3 repeating. And my label here would be miles per hour, or MPH, miles per hour. All right, the next one, Chevy walks at a rate of 3.5 miles per hour. Well, that's telling me how fast she's going, so that's a rate. And we go for a 45-minute walk, so that would be the time, right? How long it takes us. If I have rate and time, I'm looking for distance. I can go back to my triangle, and distance is rate times time. Now, the only thing to be careful with here is I have hours right there, and I have minutes here. So if you know that there are 60 minutes in an hour, 45 out of 60 minutes, this is 3/4 of an hour. So I'm going to use 3/4 so that my units match, 3/4 of an hour. All right, so 3.5 miles per hour times 3/4 of an hour. And if I put that in my calculator, I get 2.625. And I was looking for how far did we go. So that's how far we walked, okay? All right, last one, 1 mile per hour. Well, miles per hour is going to be a rate, how fast I'm going. And I swim for 0.65 miles. That's how far I go, so that's a distance. And that means I'm looking to find the time it takes. So I put my time formula down. That's distance divided by rate. My distance was 0.65 miles divided by my rate. And when I divide by 1, I just get 0.65 of an hour. So you could